I'm going to just show a couple things, and I'm going to go through questions with you from 4.3 or 4.2, whichever it is that you're on. But I just want to go through this right now. Now, one of the rules that we could have added, what we should have added to our list is this one here, where I can change a rooted value into a fraction in which this value right here, this rooted value, goes on the bottom of my fraction over here. Okay, so if I have the nth root of x to the n, I can rewrite it as x to the n over m. So the denominator of the fraction in all of these is always the value that goes on the outside of the root there. So if I was looking for the 4th root or the 5th root or the 6th root of something, it would be written on the outside of that. Okay? So, to give a couple of examples, so the cube root of 10 can be written as 10 to the power of 1 over 3. All right, we just write it as a fraction. Let's say I have the 5th root of x to the power of 7. That'd be written as x to the power of 7 over 5. That's right. Okay, so the rooted value always goes on the denominator of the fraction that we are working with. All right, now the next thing I want to talk about, okay, is what a radical is.
Yeah. Basically like roots.
Yeah.
Basically like roots. They're really weird.
They're roots that are not, you're not able to find the perfect square of, or the perfect cube of, or the perfect, yes sir.
Oh, by the way, if you have like a triangle with the adjacent and opposite of them 1, you'll get the square root of 2 radical as the hypotenuse.
If the angles are the same, yes.
Yeah.
Yes, that's correct. Yeah. Okay. So we can write it as a mixed radical. So 6 square root 2. That's what we refer to as a mixed radical. All right? In which the square root represents what we call a radicand. Okay? And the 6 is the whole number on it. All right? Now, what you have to be able to do, okay, is be able to take a single radical, all right, or square root, and convert it into a mixed radical. So this is basically the start of 4.4 and what we want to be able to do. So for example, if I have the square root of 18, let's say, okay, is 18 a perfect square, yes or no?
No.
No, it's not. Is there a number that I can divide into 18 that is a perfect square?
16. 9.
What is it?
9.
9. Is 9 a perfect square?
Yeah.
Does it divide evenly into 18?
Yeah.
9 times what gives me 18? 2. So I can rewrite this as square root 9 times square root 2. Now, because they're both under the roots, I can actually multiply them together. So root 9 times root 2 actually gives me root 18. Well, what is the square root of 9? 3. So I can write this as a mixed radical then. 3 square root 2. That is the same as the square root of 18. Okay? We okay so far? All right, we're going to do a bunch of these. How about I do a couple more and then I'll, go ahead, bro.
So that's 6, so whatever I know how to say it, would
6
be,
square root 2.
yeah, it would be 38. Okay. No, 40. No, I don't know.
Okay, I like what you're doing. I absolutely love what you're doing. You're trying to work it backwards. Let's do that. Okay, so let's look at it like this, okay? So I'm gonna work backwards here, because she's trying to figure that out, and I think it's great, because this is the other aspect of it. This is something else that we have to do with it, so this is awesome. So what we're gonna do then is this. Remember, this is a perfect square, right? So this could actually be written as square root 3 squared times root 2. Would you agree with me? 9 can be written as 3 squared. Okay? Now the squared and the square root, they cancel each other out because they're inverses of each other. Agreed? All right? So what I can do then is I can add a square root to this as long as I do what to it? Square it. So let's do that. I'm going to add the square root and make it 6 squared times root 2. Follow what I did there? I added a square root. I also added a squared value, which cancel out and still give me 6. That's what I started with. So far, so good? What is 6 squared? 36. What is 36 times 2?
72. Oh.
There's your answer. It's square root 72. You follow that?
So if that 2 is a 3, you'd have to times it by 3.
Yeah, that's right. Okay, so we're gonna do a couple more just to get you started. I want to let you go through 4.1 to 4.3 and do a really good job of it. I really want you to get that done, okay, for Monday. So I'm going to give you lots of time today to do it because some of you missed class yesterday, and that's the way it is. Okay, so I want to get this started so that it's not brand new to you the next time I show it to you. Because what I find is when I learn something brand new and then I got to go and apply it, I have trouble with it. But if I have seen it once already and then I come back to it, it's not as new to me, and I think I can do a better job of it then. All right? Okay. So let's look at a couple different examples. I'm going to follow through page 75, and I'm going to go through all the questions on 75 with you. So there's 12 questions there. So the first one says, convert each of the following as requested. Express each power as an equivalent radical. So I need to change 32 to the 1/2 and make it a radical. So by making it a radical, I'm applying a square rooted or a rooted value to it. Okay? So how do I write that as a radical?
Square root of 32.
Square root of 32. Do I need a 2 here?
No.
No, I don't. I can place it there though. It's not wrong. But we understand that if it's square root, then that means that it's a fraction of a half. All right? Okay, the next one is 16 to the 2/3. Okay? 16 to the 2/3. How do I write that as a radical? Put up your hand if you think you can do it. Lily, half up. I got you.
16, wait, the power of 2, and then like the third or cube.
Yeah, there girl. You did real well. Okay? So the cube root of that. That's what the 3 stands for, right? Yeah? And then I just put 16 squared in here.
That makes sense.
Yeah, that makes sense.
That makes sense?
I was thinking that, but not really.
Okay. All right, so okay, so I'm going to show you, I'm going to work it back so that it makes more sense. Okay? So if I worked it back, I would go 16 squared, bracket,
Excuse the interruption, next I go to root 23, next to root
1/3, like that, right? Because that would account for the cube root. So when I times 2 by 1/3, what do I get? 2/3. So I worked it backwards and I ended up with what I started with. Okay? All right? Okay.
So if they ever wanted you to like solve that,
Well, we're going to get to that. I would go from here. I'm going to show you this. This is actually 2 to the 4th, to the 2/3. All right? 16 is 2 times 2 times 2 times 2. Okay?
You do 4 squared too.
And so I would times the 4 by 2. So to solve it, to get it by itself would be this. So this one doesn't work great. This one doesn't work great. So then that's what it would be. It would be 2 to the 8 over 3. What would this be? Somebody tell me, put up your hand if you think you can put that into a radical 2 right now. Put up your hand if you think you put that. Go ahead, Brooklyn, try it then.
The cube root?
Cube root?
Yeah. And 2 to the 8.
2 to the 8, that's right. That's right. Okay? Okay so far? All right, I have 8x cubed, in brackets, to the 1/4. Go ahead.
Is it 4 cubed to the 8x?
4th root, no, you're right. It's 4th root.
To the 8x cubed?
Yes,
Oh,
yes it is.
I did it correctly.
Good for you. There it is. 4th root, 8x cubed. All right? Yes, Brian?
So basically, you just have to take like the bottom, like the denominator, just put it in front, just like root that.
Very basically, yes. That's exactly what happens. Yeah.
Then you times the radical.
Okay? I like the fact that we didn't distribute this. Okay? What we are learning in 4.1, 4.2, and 4.3 would be to distribute this. So that would be 3/4, and that would be 1/4. So it'd be 8 to the quarter times x to the 3/4. But we're not there. We're not doing that. We are just simply converting to radicals. Go ahead, Maya.
How would you do it if it was like 8x cubed to the 3/4?
3/4? Okay. Okay. Everything stays the same so far.
Then 6/4? Yeah, it's an x.
4th root now.
9/4.
Now watch what happens.
Oh, yeah,
8x
cubed.
So I've got that right now. I'm showing you in steps. Showing you in steps, right? And then I would probably, now I would distribute 3. 8 cubed, x to the 9. Okay? And then I would probably change 8 cubed into whatever 8 cubed is. 64 times 8, whatever that is. Okay? All right, now we're going to work backwards. So, change this so that I have an exponent here. What is that going to be as an exponent now? Six to the power of what? 1.
Yeah, 6
Oh,
and 1.
3
2
over
over
2.
1.
Grayson?
6 to the power of 3 over 2.
Okay, so I did this earlier. I'm going to show you this in 2 steps. This is actually 6 to the 3, right? To the 1/2. Agreed? The rooted value is now written as a fraction, to 1/2. And then when I multiply 3 by 1/2, what do I get? That. Yes, no, maybe so. Okay. Try another one. Try it on your paper. Put up your hand if you think you've got it. No, Lily? Anybody else think they've got it? Try it. Grayson, Brian, Myra. Hey, Lindy, you got it? Maybe. Ed? You think so? I hope so. Emma? Think so? I'll give it to me.
I don't
Atta girl. How many of us got 5 to the 2/3? Oh, you guys are all... Come on, you gotta put your hand up when I say, do you think you got it? Look at it. Everybody gets it, and we all keep our hand right here. All right? 5 squared to the 1/3 is 5 to the 2/3. Okay? Anyone? Does it make sense? Okay. We'll put the pressure on you then. Pressure? Oh, this one's a doozy. Oh. The letter T. 8 cubed. Anybody want to put a finger up? Okay. You might not see me if I put my finger up. Right?
I see it.
Is everybody done? Everybody's had a try? Okay. Who wants it?
8 to the power.
3/10.
Hey!
Oh, I thought it was
Good thing you put a finger up. Should have put your whole arm up, because I got it. Right? So all I got to do is move that number that's in front and put it on the bottom of the fraction. That's it. Easy peasy, right? Okay. So far, so good. Now we're going to get into a little bit more difficult stuff. All right, so I'm going to, and it's actually not. I shouldn't say it's difficult. Once we get the process down, it's fairly straightforward. So we are going to take a mixed radical, and we're going to change it into an entire radical. So that's what we just did. I'm going to do it one more time. So I'm not following the book here. I want 2 square root 3 written as an entire radical. So not as a mixed radical. So we need to write this as an entire radical. So I just finished doing this with 6 square root 2, right? You remember that one? Okay. So what do I have to do first? Lily, go ahead.
You put 2 to the power of 2, and then cube it, and then put the thing.
Not cube it,
Or
yes.
not square it, and then
Square root it, yes. I think I heard Eli say the same thing. Okay?
12.
Square root of 2 squared times square root 3. What did you get, Eli?
Square root of 12.
Square root of 12. Right? 2 squared is 4. 4 times 3 is 12. Okay? Yes, no? Who's confused? Put up your hand. Big and high one. All right. Okay, what part of it am I losing you on?
If like 3 is squared, how can you just hide it like 3? I'm not doing anything else.
If I have a square root here,
Yeah.
and you're asking why I can just multiply?
Yeah.
Because they're both in rooted values. I can rewrite this, Brooklyn, like this. I can write it as 1. As long as they are both the same roots, I can actually multiply them. So let me show you in a different way that'll make a little more sense. Okay? Imagine this. I take the square root of 4 and I times it by the square root of 4. Okay? So I'm taking square root of 4 times square root of 4. Well, what is the square root of 4?
2.
2. So would you agree with me that this is 2 times 2? So I would get 4 there, right? Okay. If I take the square root of 4 and I times it by the square root of 4, I'm going to get the square root of 16. Because 4 times 4 is 16. You agree with me? What is the square root of 16?
4.
4. The same thing. So if they are both in rooted values, I can multiply them. All right? I can't multiply 2 times square root 3. But I can multiply the square root of 2 squared times square root 3. Does that make sense? Okay? All right, let's try another one. All right? Change that into an entire radical. You see some right answers already. Okay? What's the first thing I should do here?
Square root of 5 squared.
Say that again?
Square root of 5 squared.
Square root of 5 squared times root 2. What is 5 squared? 25. What is 25 times 2? 50. Haley, did you multiply 5 squared wrong?
Yes.
Did you put 10?
Yes.
That happens
Yes.
all the time.
Yes.
All the time. All right. Okay? But you did that right here, correct? You did this right. You just multiplied 5 times 2 instead of 5 squared, right?
Yep.
Okay, perfect. Easy fix. Okay, so now we're going to make it a little bit more difficult. Okay? Don't let that scare you at all, because it's still the same process. Remember, my objective here is to not change the question. So that means I have to do the inverse of what I'm going to do. Eli, you think you got this?
The first thing you do is the cube root of 2 cubed times the cube root of 4.
Okay, so the first thing I do, Eli says, is cube root of 2 cubed. I agree with them 100%.
And then the next thing you do is you solve the cube root of 2, and you multiply that by 4, and then it's the cube root of that answer.
Okay, so I'm not going to solve for the cube root of 2. I'm going to solve for 2 cubed, right?
What's the difference?
What is 2 cubed?
8.
2 cubed is 2 times 2 times 2.
8.
The cube root of it means you would take
Oh, that's right.
the cube root, right? So what it is what number do I multiply by itself 3 times to get that value?
The answer's 8.
Okay, so what is the answer here?
8.
The answer here is 8, right?
Times 4.
8
Times 4, which is?
36.
Close.
32. Yeah.
Go ahead.
What I tried is I did like 2 to the power of, or like cubed and square root. And then I times it by just the square root of 4 and I got the same answer, 32. But just not like the square root or the,
Square root.
yeah. What did you do?
Say that again.
Like I timed, like I cubed the 2.
Yeah.
Then I square rooted it. And then I times the 4 square root. And then
Yeah.
I got the same answer.
Yes.
The cube, just not the cube.
Okay. You
Square root of 4.
you can't do, okay, so I think you're just saying it wrong, like the way you're
Yeah.
explaining it, but you're doing it exactly as I want you to. It's cube, 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 all the way across. Okay? So the cube root of 2 cubed, because remember, if I wrote this out like this, what does that equal?
Root of 3 of 2.
What do I do with an exponent to an exponent? Multiply. What's 3 times a third?
1.
3 over 3, which is?
1.
1. 2 to the 1 is? Still 2. It's still the same thing I started with. Okay? All right, let's try one more. Try and keep it as simple as possible. Okay?
Oh, we're trying to solve this. You'd find, for the answer, you'd write 4 root of 3 fourth, or root to the power 4, multiplied by the 4th root of 2.
Yes, you're right. Okay, so add my 4th root in, and because I added the 4th root in, what do I have to make 3? 3 to the power of 4. That way they cancel out, right? And then 4th root 2. So 3 to the 4 is 81. Times 2 is 162, so the 4th root of 162. Okay? And you just got that correct. All right, that's great. That's great. Anybody want to tell me why they didn't get it right or had a problem? My main focus is this part right here. If you can do that, you won't get any of these wrong. If you can just do that first step. And then maybe the multiplication can be wrong at some point, but for right now, as long as you do that first step. Okay? All right, so the last thing I want to show you today is working the other way now.
Oh yeah, that's what I'm doing right now.
Okay? So I'm going to pick, well, let's do this one. Okay, so I have an entire radical right now. I have the square root of 27. Is 27 a perfect square? No. Right? There's no number that I can multiply by itself to get me 27, is there? Okay. So I asked you at the start of the week to write at the top of the page all of the perfect squares and all the perfect cubes. This is why I told you to do it, for this right here. What is the largest perfect square that divides evenly into 27? Is 3 a perfect square? 9 is a perfect square. Does 9 go into 27?
Yeah.
How many times?
3.
Right. So I go like this. Square root 9, square root 3 now. So rather than have the square root of 27, I'm going to have the square root of 9 times the square root of 3, which is the square root of 27. What is the square root of 9? 3. So I write that as 3 square root 3. That is taking an entire radical and making it a mixed radical. So the biggest thing is I have to be able to find all the perfect squares that go into those numbers. Okay? Now, I'm going to show you one. Out of the book now. Square root of 112. All right, I need a perfect square that goes into 112. And preferably
Mr. Neufeld to the office, please. Mr. Neufeld to the office.
Preferably the highest one if I can. But if I don't get the highest one, I don't need to use it. I can just keep breaking it down. So give me one that you think goes into 112. What's the largest number? What's that?
10 squared.
10 squared gives me what? 100. Does 100 divide evenly into 112?
No.
No. So it can't be 10 squared, but I get it. I like what you're thinking. All right? So I need the largest perfect square that divides evenly into 112. All right? These two numbers right here should give you a hint. What is the largest number that you can think of as a perfect square that goes into 12?
4.
4. So 4 goes into it. Because it goes into the last two numbers, 4 goes into it. Is 4 a perfect square?
Yes.
Yeah. So we could start it like that. I could go square root 4 times what gives me 112?
28.
28? Okay. What is the square root of 4? 2. Now, I want you to look at 28 for a second here. Is there a perfect square that goes into 28? Is there a number that goes into 28 that's a perfect square? 7 a perfect square?
4.
4? Is 4 going to 28? How many times? Brandon, you just said it. How many times? Yeah. How many times is 4 going to 28? 7 times. So now, watch this. 2 times square root 4 times square root 7. We following so far? Yeah? What is the square root of 4? 2? Okay, so now I have 2 times 2 times root 7. Right? What's 2 times 2?
4.
4. 4 square root 7. Okay? Can somebody tell me the largest perfect square that goes into 112? Perfect square. The largest perfect square that goes into 112. We didn't pick it. What is it? Look at the board. Haley? 36?
I'm just guessing on there, I actually have no idea.
Need a perfect square? Think of your perfect squares.
Probably 16.
Emma?
16?
16? Somebody else said 16 over here? I want to show you something. Okay, put your pencils down for 1 second. My new question to you is this. Change this mixed into an entire. Change it into an entire radical. So what do I do first?
4 square root.
7.4.
So I go square root of 4 squared. Yeah? Times root 7. Agreed? Yeah?
Oh, yeah.
What is 4 squared?
16.
16. What is 16 times root 7?
112.
112. What was the largest perfect square that went into 112? 16 it was.
Would you ever have to do this with cube root?
Yes. Yes, I will.
Would it be different?
That's why I told you to know the first 5 perfect cubes. For that very reason. All right, so I'm going to do that exact same thing after I just have that discussion with you about this. We understand what happened there. Now, I didn't pick the largest perfect square, but I can keep breaking it down so that I get that. My largest perfect square was 16. Okay? Last one, and then I'm done for today. It's the cube root of 32. I need to break down the cube root of 32. So I asked you on day 1 of this week, know your perfect cubes. What is the largest perfect cube that goes into 32? Evenly. What is it? 8. And how many times does 8 go into 32? 4 times. So I change that to cube root 8 times cube root 4, right? What is the cube root of 8?
2.
2 times 2 times 2 gives me 8. Therefore, the cube root of 8 is 2. I went from an entire to a mixed. All right? You okay? Huh. So? Time for a break? Okay, I'm just going to shut the camera off, and we'll go through questions from 4.1, 4.2, and if you need 4.3. So pull that out for me right now.